Hello everyone, my name's Adam and welcome back to the channel. And today we're taking a look at the Prusa i3 Mark III regarding issue 602. So what is issue 602? Well, it was an issue found with the Prusa i3 Mark III and posted on the 5th of April on GitHub with the title of Inconsistent Extrusion, so that's probably what you're more familiar with it being called. It's an issue regarding inconsistent artifacts of print quality on prints that we know are not attributed to things like Z-wobble and the Moiré effect, where artifacts tend to be more consistent. So this is a sort of inconsistent, it looks like inconsistent extrusion, and that's how it was first analysed, hence it got that title. But it's more of an issue regarding just an inconsistent appearance on a layer or on a set of layers on a print. I think a better name for it would be inconsistent layer artifacts, based on the fact that we don't really know the exact source of the issue, only what it looks like. If you want to know more about the issue and what it looks like, there's a link below to the GitHub discussion where there's plenty of posts and images about what it looks like, what it isn't, and what it is. So what's been done about it then? Well, of course, I made a video, and that seemed to raise quite a lot of awareness, which was sort of the point. There's now a Discord channel where there's 400 people talking about the issue and a smaller number of people actively investigating the issue to find out exactly what the problem is. And that was going on for a number of weeks. In addition to that, Prusa Research had their own sort of independent developers working on it just to see what they could discover separately to what the rest of the community would discover. And one person, Imrija, I'm not sure quite how you pronounce it, but this is a person in the Discord channel who has done quite a lot of work and even travelled to Prusa Research in order to discuss his findings with them. So there has been a lot of investigation going on as to how this issue is caused, what it is, and how we can go about fixing it. For those that don't already know, Prusa Research did have a post to sort of address some of this issue in their most recent blog post, and I'll leave a link to go and read that. I'm not going to be actively discussing that exact post here. I'm going to go through ways that you can solve it. So ways to get around the issue, ways you can fix the issue, ways you can reduce the issue, and a couple of ways of why this is the case and a couple of reasons of how, and there'll basically be plenty of details to get you a little bit more clued up to make sure you get the best out of your Mark III. Really, the aim of this video is to ensure that you get the print quality that you're expecting from your Mark III. If you're having something that looks like issue 602, then hopefully this video will give you the instructions you need to reduce it to a point where you no longer notice it as much. It's very difficult to completely get rid of it, but for now we're going to go through this list and try and reduce it as far as possible to get you decent print quality. So the first issue is loose extruder screws, and by that we're talking about the screws that hold the X carriage to the extruder. They go in through the back and can tend to loosen over time or be difficult to tighten in the first place. As a result, if they're not tight or not rigid, then you get a lot of movement between your hot end basically and the axis that's trying to determine its position. All you have to do to solve this is tighten the screws. Quite simple. The next issue is bearing quality. If you've got any slop in your bearings, if there's any wobble, or especially if they're sort of gritty and grinding, then that's a significant issue that you need to solve. The bearings that come with the printer are not particularly great quality, so you may want to completely swap out all the rods and bearings with something higher quality, such as something from Mizumi. However, that could cost you quite a lot of money, and if you don't really want to do that, well, there are alternative solutions. One of those solutions is PLA bearings. They're not particularly easy to set up. They do take quite a bit of time to get them just right, as if they're not quite right, then they're not much good. But once you've got them right, they're a great, silent, and fairly long-lasting solution. The next thing is loose Z-axis rods, which of course the smooth rods are here and here. You want to make sure that these are stiffly mounted. So if you hold this part and this part, if there's any rattle between the two, if there's any movement, then that's no good. You want to make sure that they're firmly in place. If they're not firmly in place, then maybe your screws are loose up here or down here. Maybe your parts are not quite the right size and you could reprint them. There's a number of things that could cause it. Maybe this part's just a little bit wobbly at the bottom. Maybe you need a stiffer Z-axis mount. But as long as they're stiff and rigid and don't move, then they should be okay. The next one is the Z-axis nuts. Now typically the way these are installed is they get mounted onto the parts get assembled into the whole carriage, and then the whole carriage gets plonked onto the z-axis. Now the problem with that is that you don't necessarily know that the alignment of these bearings is correct to the alignment of the rods. What you should do is put the nuts onto the parts loosely, don't tighten them down. Then assemble everything and then tighten the nuts. That way your nuts are based on the position of the rods rather than just some arbitrary position that you happen to tighten them into. Fortunately, this one's quite easy to fix. All you need to do is loosen both screws at each end, and that'll let the nuts settle to their intended position, and then just tighten them again. You should find that this helps the motion of the z-axis be a little bit more consistent. Next, we have the loose hot end in extruder assembly. So basically, we need to check if the hot end assembly is loose. So we grab the hot end only when it's cold. Cold, not hot, cold. Give it a little wobble. Move it backwards and forwards. You can be quite firm. In fact, you should be quite firm. But I mean, you don't want to try and break the printer. You're just trying to see if there's any wobble. It shouldn't have any little rattles or any movement. It should be firmly fixed in place. There are a couple of ways you can solve this. First of which is to reprint the parts. Maybe increase your extrusion multiplier to maybe 1.05 or 1.02 even, just to get a little bit of over extrusion and maybe hold that hot end in there a little bit tighter. An alternative is to add some tape around the top and bottom of the heatsink of the cold end. You don't want to cover any of the gaps between the fins, just literally around the edge of the fin. Just a tiny bit to increase the diameter of that cold end and make it seat into the parts a little bit better. It's not a particularly ideal situation, but it does need to be rigidly mounted. If it's not, then you're going to get artifacts. Next we have another hot end related issue, the ptfe tube. The ptfe tube inserts down into the hot end, well, mainly into the cold end. But you need to make sure that the ptfe can't move in that hot end, cold end. It's locked to a little lock ring at the top of the cold end, and you need to make sure that as you push the ptfe down, you pull the little ring up, and that will make sure it's held in place. To get some additional sort of strength to that grip, you can print a little sort of C-clip that goes around under the other clip to stop that clip moving up and down. And that will prevent it being able to loosen off and prevent the ptfe tube from moving. Next, we have the incorrect meshing on the Bondtech gears. Now, this is not really one that you can fix directly, but there's a way around it. So the issue is that gears are a fairly precise mechanism. You set them. This is maybe not a great way to... Gears are quite a precise mechanism. They're designed to be a certain distance apart. But in a Bondtech setup, those gears have a variable distance. They can move closer and further depending on filament, depending on all sorts of things, and especially the tension. The problem with that is that unless they're set at the exact design distance, then you're going to have a problem because you're going to get sort of binding as those teeth don't mesh quite as they're intended to. To get around that, well, you can't. The only way to do it is to remove the second set of teeth. You could grind them off or do something quite drastic like that. Alternatively, you can listen to the next method and that will sort of give you the solution. So the next issue is the filament biting variation. Now, it turns out that the way the teeth bite into filament can have a fairly decent effect on the way that the print comes out afterwards. That is to say, a big teeth makes a big change to filament, makes big change to print. So the way we get around that is to do a couple of things. Firstly, to reduce the tension. You want these screws to just be tight enough to grip the filament in all conditions. So to do that, you can loosen everything off, put the filament in as if it's going to be used, tighten the screws until that will pull the filament through. Once it pulls the filament through, then it's tight enough. You don't want to go any further than that. The other thing you can do, which is a bit more drastic, is to replace the idler. So the Prusa A3 Mark II has a little sort of skateboard bearing, a ball bearing that is the idler, and it just sits there and the hobbed extruder pushes against it. You kind of want to replicate that setup here so that you don't have that meshing problem with the Bondtech gears, as well as reduced biting on the filament. Next we have the X ends being too loose. That is to say the print density is not high enough in order to get the strength of the parts that's required. The way you can test this is by grabbing your hot end or the whole extruder assembly and just moving it like you did before, and you'll notice that there's quite a lot of rotation that can go on there. Remember, acceleration forces are quite significant. So there's quite a lot of rotation there. And you might notice that as you do that, you get some separation up the seams at the end of each hot end, at the end of each X-end part. The reason is they're not quite strong enough and they just don't work great. So the way you get around this is to reprint them. Reprint them with maybe 4 perimeters and a sort of 20 to 30% infill, probably rectilinear or something like that. And that'll give you a really nice strong part which won't flex as you do this. The next one is a fairly minor issue, probably based on the investigation so far, and that is the belt rubbing. So typically on this axis, you'll get a significant amount of belt rubbing on this idler down here because the alignment's not quite right and the idler's not quite the right thing. So the way you can get around that is to replace the idler with something that's better for this application, but hopefully it's not causing too many artifacts. So if you don't do anything, you can probably still get very good results without doing anything with this one. The next one we have is linearity correction. The implementation of that, being quite a new implementation, is not really perfect. It's not great. The way we do that is to make sure the linearity correction is properly set up, make sure it's calibrated to your printer, and that should get you most of the way. Next we have the stock rubber feet. Now these obviously mount to the bottom where the printer touches the surface, and they're designed to reduce any vibration and to stop therefore noise traveling into the surface and being generated or making everything louder. So in that respect, I mean, they seem like the right thing to do. You reduce vibration, reduces print artifacts, reduces noise, everyone wins. In actual fact, it seems that a rigid foot, although a little noisier, does greatly improve print quality. Seems a little bit strange, but that's the way it is. Remember that these soft feet are not an interface in the middle of the printer that changes any distance between the Y and Z axis or anything like that. So it's strange that they have an effect, but they do, so there's that. Next we have belt quality. Now belts are rubber and fibers. They're made of rubber, so they're nice and flexible, and they have added fibers to stop any stretch. So they have to have a high tensile strength. That's what we're after here. We want to make sure that as you apply a force to the length of the belt, it doesn't get longer. It stays as close to its original length as possible, and that is high tensile strength. To get high tensile strength in a GT2 belt, you have to make sure you have a high fiber count, so lots of aramid or Kevlar fibers to stop any stretching. A low cost belt will have less fibers because the fibers are expensive. So we fill the space with rubber instead of expensive fibers. However, a Gates GT2 belt, the proper belt if you like, is much higher performance. It has much less stretch, higher tensile strength, and will perform much better on a 3D printer. So you want to replace these belts with higher performing belts. Simple as that. So lastly, and perhaps most significantly, we have the hot end cooling issue. So what we have here is the hot end fan, the cold end zone, which is the heatsink area, and the hot end zone, which is down by the nozzle. The fan should cool the cold end to keep it sort of nearish room temperature, probably a little bit elevated, but not hot enough to affect the filament in any way. It then goes into the hot end almost immediately, a quick transition zone as it becomes sort of molten, out onto the part, and then cools again and hardens. However, on the Prusa Mark III design, we have an effect where the airflow is not sufficient to keep the cold end cold enough. So what effect does this have? Well, let's imagine you've sort of stopped printing for just a moment. It's partway through the print, but it's just doing maybe a retract over here, it's moving across, and then starting again over here. Just an example. The filament has stopped moving. It's stopped moving in the cold end, which is slightly too warm, which slightly heats up the filament. As it slightly heats up, it slightly expands and slightly softens. Slightly. Now, as the print starts to move again, it's pushing that soft filament down, which has a slight bit of stiction. So it can stick to the walls. It then requires more pressure. You get this bit of a build-up in the sort of nozzle area before it comes out. So you end up getting a lot of filament sort of all out in one go as it sort of pushes and it goes whoo. So you get a and you get a it all comes out sort of gradually, and then as it becomes sort of steady state again, just constant movement, constant traffic, you get a constant extrusion width. But again, you'll have an instance where it slows down, softens, slightly expands, slight build up of pressure, slightly wider, slightly extra filament comes out, and then it reduces back to normal again. And this seems to demonstrate an issue with extrusion consistency. as you can see from these images, by printing at 200% speed and not allowing any additional time for small layers. Although adding other artifacts, it does significantly reduce this inconsistency on this part you can see here. So how can you solve this issue? Well, there are three things. The first is the Prusa revision 3 extruder. It has some sort of Venturi flow where the flow of the fan adds to an additional side flow. So it basically, the movement of the air from the fan pulls in additional air. That increases the airflow, increases the cooling capacity, and reduces the temperatures. So there are new parts from Prusa to improve the cooling design. Secondly, you can upgrade the cooling fan. So this fan here is a Noctua. It's really nice and quiet, although brown, but it doesn't really push that much air. Not only that, but the actual static pressure, its ability to push air through a restricted zone, is quite limited. By upgrading your fan to something a little bit louder, a little bit faster, a little bit more air pushy, then you can get more air through the hot end cooling area for greater cooling effect. The third thing you can do is reduce the radiation effect from the hot end up into the cold end by insulating between them. So the suggestion is to use ceramic tape. Don't know what ceramic tape looks like, but some proper method to insulate the two will reduce the radiation effect of heating from the hot end into the bottom of the cold end fins. By reducing that heat input, you require less heat output in order to retain a steady, cool temperature. So with all that being said, work is still being done to try and look into this more, to assess further features, assess further changes that could have an impact, and you'll see on the links below that some of the articles are not totally finished. They are being worked on, so bear with that. So that's it from me today on issue 602, the inconsistent extrusion that's not necessarily directly related to the amount of filament coming out of the nozzle. Thus we can call it, what was it? Inconsistent layer inconsistencies? Anyway, like the video if you liked it, share it if you think someone else might find it useful. You can support me on Patreon. You can like and subscribe if you want to see more from me. Leave a comment down below letting me know your thoughts and feelings. Follow me on Twitter and Instagram for behind the scenes things and fun like that. Thank you very much for watching again, and I shall see you in the next one.